Okay, now we're going to look at the actual circle theorems. Now, in each of these diagrams, I have color-coded various parts of the diagram. So, for example, here we have a red diameter, and you can see that the red diameter is indicated by this line here. So that word there is diameter, for example. Before we do that, I just want to introduce the idea of the concept of subtending angles. So let's just do that quickly. Subtending angles. Okay, so if basically to subtend an angle, if you start with a line segment, then you can subtend an angle. Imagine placing your fingers on either two fingers on different hands on opposite ends of those that line, and we bring them together in straight lines. Basically, what we create is an angle. So imagine we have our fingers on here and here, and we bring our fingers together along into a single point, and we get down to this point down here. Then that is called the angle subtended by the line segment. So this is the angle subtended. Oops, sorry, this is the angle subtended from a line segment. And notice that I could subtend the angle in lots and lots of different ways, an infinite number of ways. I could have subtended it like this. So I put my fingers on here, and then subtended upwards towards this angle. So this is also an angle subtended from a line segment. They're not equal necessarily. As you can see, I could have this angle is also subtended from the same chord. But they're all angles subtended from a chord. So that's that. What we're going to do now is fill out this information about the circle theorem. So the angle that we're creating here is the angle that's subtended from a diameter. So that word that goes in there is subtended. The angle subtended from a diameter, which is our red line, to the circumference of a circle is, and it creates a right angle or 90 degrees. So the angle subtended from a diameter to the circumference is 90 degrees. Number 2 here. Here, what we're doing is we've got a chord here, so that's definitely chord, and we're creating angles subtended from that chord. So the angle subtended from a chord to the center, so that's this angle here, this is the angle subtended to the center, and notice it is twice as big as the one which is subtended to the circumference. Okay, so the angle subtended from the chord to the center is twice or double that subtended to the circumference. And in actual fact, notice that when we create this chord here, we're creating two segments. This one, this tiny little one here, and this much bigger one there. The rule is that the angles must be subtended into the same segment. So we'll write that down in there as well, into the same segment. Number 3. So again, we're subtending angles. This time we're subtending angles from this chord. So we'll write chord in there. The angles subtended from a chord. So this angle is subtended from this chord, and this angle is also subtended from the red chord, and they're equal. So the angles subtended from a chord into the same, well, it must be the same segment again, are equal. Okay, so take this chord, subtend an angle here, subtend an angle here. We could subtend another angle, let's say up here. This would also be x, as long as it's into the same segment. I couldn't subtend it down here. That wouldn't work then because it's in a different segment. Number 4, what these are called radii, so that's the plural of radius. 2 radii form an, what sort of triangle is this? Well, these 2 angles are the same. I would say it's not particularly well drawn, really. It might have been better to draw it like this, just to, so I'm going to draw my radii slightly differently. Let's say it like that. Then my radii. So 2 radii form an, so I'm then going to draw my straight line here. What sort of triangle is that? Well, that is an isosceles triangle because these 2 angles are the same. And that's what this says. 2 radii form an isosceles triangle and therefore equal angles. Sometimes in questions you might see lines written like that, indicating that they're the same length. And they are the same length because they are radii.